Let us discuss briefly and drive through the concept of balance of the drift and diffusion current in a PN junction and the reason behind it, that why it happens so. And once it becomes balanced, the built-in potential stays on there. That built-in potential has to do with this forward and reverse bias, and all we see the function of these diodes, transistors, the chip in which would have billions of transistors, and all there is this particular N and P region formed because of the N groove in P-type substrate in N-channel MOSFETs, or the P-type groove in N-type substrate in P-type channel MOSFET. So the reason or the working principle at the region, that is at the junction between P and N, is discussed what happens and why this current occur to have this particular direction. So let us see that. Now in any particular PN junction, if we see, let us draw an isolated PN junction to understand the physics behind it. So in P-type region, what we know is there is an impurity atom boron which is doped into it, into the crystal lattice of the silicon substrate. So this crystal lattice having boron is having a hole because of the gap of, or the less number of valence electron available in boron atom, that creates a gap which is shown as these holes. And similar to it, the other part of the semiconductor, silicon semiconductor substrate, is doped with phosphorus, which has 5 valence electrons in outermost orbit, which when bonded with silicon having 4 outermost electrons leaves an excess 1 electron in each atom, but with each atom of phosphorus. This excess electron within this crystal region or within this particular lattice of material is available for conduction. So these electrons are present available in N-type region, and these holes which are present on the other side is called as P-type region, because this act as a positive charge thing, even though that does not carry any charge, or this particularly a region which is space empty, that is called as a gap or a hole, which can take up an electron, acts similar to that of a what you call a positive charge. So that is the reason why it is called as a P-type region. Now at this junction there is so much of physics and dynamics happening, which is causing this PN junction to behave as a switch or as an amplifier. Let us first see what happens exactly at the junction. Now across the junction there are two different charges of high concentrations. These are called as majority charge carriers because they are present in vast concentrations on, like in N side it is electrons and P side it is holes. Now these electrons which wants to go out of this particular region because they are so tightly packed up, they repel against each other, so they want to go to the other side where there is very less electrons, which is the magnetic charge carriers now on the other side. Now this electron when move towards the other side, this particular region is free of one electron, so becomes positively charged because electron negative charge element, when negative charge particle, when it goes out, the protons present in the nucleus become one more. One loss of one electron will cause one proton to become